In this video, I'm going to show you how to conduct a goodness of fit test using the LibreText calculator. The question asks, are phone calls equally likely to occur during any day of the week? The day of the week for 588 randomly selected phone calls was observed, and the results are in this table here. And we want to check at a 0.1 significance level if that distribution fits a uniform distribution. So a uniform distribution would mean on every day of the week, you get the same number of phone calls. So the expected frequencies are going to be 588 phone calls divided by 7 calls per week, and that's 84. So all the expected frequencies in this problem are going to be 84. Okay, and as I stated above, we're conducting a goodness of fit test to see if the numbers that were sampled fit a uniform distribution. So the null and alternative hypotheses. The null hypothesis is that the distribution of phone calls is uniform over the week. And the alternative hypothesis is that the distribution of phone calls is not uniform over the week. The degrees of freedom for this test, you don't need this to use the calculator online, but it's good to know in case you're using a different software. For a goodness of fit test, the degrees of freedom is the number of categories minus 1. And so there's 7 days in the week, subtract 1, and we get 6 degrees of freedom. For the test statistic and the p-value, we're going to jump over to our list of calculators, go down to goodness of fit, and type in the observed frequencies and the expected frequencies. So the observed are 89, 84, and so forth. And now I'll type in the expected frequencies, all 84, and hit calculate. And here we get the test statistic and the p-value. So we are asked, let me jump back over here, we are asked the test statistic to 3 decimal places, so that's 6.738, and the p-value to 4 decimal places is 0.3457. Okay, the p-value in this case, 0.3457, is greater than the significance level of 0.1. And so the rule is if p is low, the null must go. If p is high, the null will fly. So in this case, p is high, so we fail to reject H0. And if we're failing to reject H0, our final conclusion is that there's insufficient evidence to conclude that the distribution of phone calls is not uniform over the days of the week. I hope this helps.